A very good evening to all of you. Myself, Dr. Prateek, your ENT tutor. Today we will discuss about anatomy of inner ear. We all know inner ear is the innermost part of the hearing system or ear. So inner ear, it consists of two parts. First one is the bony part and then comes the membranous part. So our inner ear consists of bony labyrinth and membranous labyrinth. Bony labyrinth, it is the outer shell. As try to remember the coconut. The coconut consists of outer hard shell, and inside that we all know that whitish eatable thing is our suppose membranous labyrinth. So similarly, inner ear, it is a closed cavity which is comprised into bony outer shell, which is known as bony labyrinth, and the inner one is membranous labyrinth. So let's look out at the diagram. You can see the central part is the vestibule. The central part is the vestibule, and these are semicircular canals. We all know there are three semicircular canals, and this is our cochlea. Okay. So firstly discuss about the vestibule, which is the central chamber. This vestibule, it consists of the lateral wall, which is facing towards external ear, and then consists of medial wall. So laterally there lies the oval window. Oval window laterally. Medially, utricle and sacules are present. Here in this diagram, we can appreciate the utricle and the sacule. So on medial wall, utricle and sacule rest, and these utricle and sacule are responsible for linear acceleration and deceleration. Okay, so this sacule is a spherical recess. Its shape is spherical. So how we can remember? S stand for S. That is spherical is for sacule. Why this is we are pointing towards this? It has been asked in the exam. So sacule is spherical recess, whereas utricle is elliptical recess. And below this elliptical recess, that is below the utricle, there is a duct which is known as endolymphatic duct, which connects to endolymphatic sac. So there is an opening opposite or next to the utricle connecting to the endolymphatic system. And this utricle, then posteriorly it is connected to three of the semicircular canal. What are these? Posterior semicircular canal, horizontal semicircular canal, and superior semicircular canal. Now, look at this diagram. Another part of the bony labyrinth is semicircular canal. We know semicircular canal are three in number: posterior, superior, and lateral. These all semicircular canal, these are right angle to each other. That is at the angle of 90 degree. Okay, and these all semicircular canal, they have one dilated end, that is the ampullated end, and in this ampullated end lies the sensory part of the semicircular canal, which is known as crista ampullaris. Okay, and these ampullated part are three number, whereas the non-ampullated end of the semicircular canal, there are two in number. Why two in number? The posterior and the superior semicircular canal, non-ampullated end, they just join together to form the crus commune. This is crus commune. So these semicircular canal, they open up or connect with the utricle with the help of the five opening. The three openings are the three ampullated end of each semicircular canal, whereas rest of the two ends, one is a crus commune, which is a conjunction or the mixing up of posterior and superior semicircular canal, and the last one is the lateral semicircular canal, non-ampullated end. In this diagram, you can also see the cochlea, which is the third part of this bony labyrinth. So in this diagram, you can see the cochlea. We all know this cochlea is taking spiral turns. So how many turns it takes? Around 2.5 turns around the central modulus. So what is the central modulus? Modulus, we can just try to understand. It is a central axis around which this cochlear turns are taking place. So these are 2.5 in number. It is again an examination question, and this modulus is directed against the direction of the internal auditory canal, or we can say internal auditory meatus. Look at the diagram of the cochlea. You can see these are the cochlear turns, and these are the yellow structure. These all are the neural bundle, that is the nerves which are continuously emitting from these turns of the cochlea, and they are running around the central modulus and forming the auditory nerve. You can see that these all yellow structure. So this is my auditory nerve. This is how it forms, and this is how this cochlea take turns. So around this modulus, this osseous, or we can say bony spiral lamina, it winds around the cochlea incompletely, and thus giving the attachment to the basilar membrane. So now look at this diagram. The basal turn of the cochlea, which we can see here. So this basal turn of the cochlea forms the promontory. What is this promontory? We try to remember the middle ear diagram. In the middle ear, the medial wall, if you remember, we can see, suppose this is my medial wall of the middle ear. So center, and suppose this is my facial now running like this. Okay, so center, we all know there is an area known as promontory over the medial wall of the middle ear. So this promontory is formed by the basal turn of the cochlea. Okay, now look at this diagram. In this diagram, we can see the inside structure of the cochlea. So this cochlea is divided into three parts. The first one is scala vestibuli, then comes the scala media, and the third one is scala tympani. Okay. So this scala vestibuli is connected with the stapes footplate, as you can see in the diagram. This stapes footplate, we all know in the middle ear, the stapes bone, the part is the stapes footplate, which is directly connected to the oval window. What is this oval window? Oval window is an entry gate to scala vestibuli. Whereas the round window, which we remember in the middle ear, this round window is shown here, which is just opposite to the scala tympani. That means this round window is an entry gate to the scala tympani, and both the scala vestibuli and tympani are filled with perilymph. Perilymph is somewhere similar to the CSF because it is directly produced by the CSF. CSF, we all know there is a link between the inner ear, that is the scala tympani. It joins with the CSF system of the brain. I'll show you in the next slide that. So this is how scala vestibuli and scala tympani are lying opposite to the oval window and the round window, and in the midway lies the scala media, which is the middle structure. And one more thing, this scala vestibuli and tympani, they are connected to the each other by means of helicotrema. That is at the apex. You can see there is an connecting zone at the level of the apex, which is known as helicotrema. This helicotrema makes it possible for the movement of the fluid from the scala vestibuli into the scala tympani, and we all know that's how the sound vibration are transmitted. As the stapes bone vibrate, this vibration goes into the scala vestibuli, moving the fluid, and this fluid then through the helicotrema enters into the scala tympani, and we can see the bulging of the round window also, because this scala tympani will push towards the round window, showing a bulge in the round window. Now, this bony cochlea, I've already told you, has a three-part: vestibuli, media, and tympani. Vestibuli, tympani, media, perilymph, filled with the perilymph. They communicate with the helicotrema. Scala media, it is endolymph. This scala media, which is the middle part, it is the endolymph. It is not similar to CSF. That's why it is having a voltage of plus 80 millivolt. And again, this is an examination question has been asked in the exam. So how this endolymph is produced? This endolymph is produced by stria vascularis. Stria vascularis, again the examination question, everything is written, you can see in the next slide. And we all know the scala vestibuli covered by the footplate, whereas the scala tympani covered by the round window, that is also known as secondary tympanic membrane. And what I was telling you, this scala tympani is connected to the CSF space by means of aqueduct of cochlea. So this aqueduct of cochlea connects scala tympani with the CSF. Again, this has been asked in the exam, so try to remember this thing, that scala tympani is the part of the cochlea which via the aqueduct of cochlea connects with the CSF space of the brain, whereas the scala media consists of endolymph where the voltage is plus 80 millivolt. Now again, this is an cut through section of the cochlea where we can see this bluish fluid is the perilymph, above one is the scala vestibuli and lower one is the scala tympani. Now you can see middle one is the scala media. So in the media, this is my basilar membrane. This is the basilar membrane. And over this basilar membrane lies the organ of Corti, and this organ of Corti is the sensory neuroepithelium system which is helping in conduction of the sound. This organ of Corti converts this sound energy into the electrical energy by means of hair cell. So I hope you are getting the point. Scala vestibuli, media and tympani, and the sensory part lies over the basilar membrane which is known as organ of Corti, and this organ of Corti consists of outer hair cell, inner hair cell, and thus helps in transduction of the sound energy into the electrical energy which is being transmitted by the means of this spiral ganglion as shown in the picture, and they forms then the auditory nerve. Okay, so this is all about the bony labyrinth. Now let's talk about the membranous labyrinth. You can remember the outer shell, that is the bony part, and the inner part is the membranous labyrinth. This membranous labyrinth, as shown in the picture, again contained in that bony shell. So it consists of firstly the semicircular canal ducts. So as shown in the picture, there are three semicircular canal ducts, which is a membranous part: posterior, superior, and lateral. Then comes the saccule and utricle. This saccule and utricle again are the membranous part which lies in the central chamber, that is known as the vestibule. And then comes our endolymphatic system which is known as endolymphatic duct and the endolymphatic sac. You can see in this diagram, this is our endolymphatic system which is known as ductus endolymphaticus, and it is connected to the utricle and saccule by the endolymphatic duct, then entering into the endolymphatic sac. And then lastly comes the cochlear duct, which is the innermost part, or again we can say the cochlear duct is nothing else but the scala media. So this is our cochlear duct which is known as scala media, which I have already discussed, consisting of the endolymph. Now let's talk about the cochlear duct. It is also known as scala media. It appears triangular in cross section. You can see in this diagram it is somewhere triangular. Okay, and it consists of the basilar membrane we have already discussed, which have the organ of Corti, which is responsible for the transduction of the sound energy into the electric energy. And this basilar membrane separate the organ of Corti, or we can say scala media, from scala tympani. And this stria vascularis, it secretes the endolymph. It secretes the endolymph. Again, very important examination question has been asked multiple times, like in 2002, 17 or 13. Now, this cochlear duct, which is the scala media, it is connected to the saccule by ductus reunion. Okay, so we all know the utricle and the saccule. These was the part of the central chamber, or we can say the vestibule. This utricle has a 5 opening by means of semicircular duct, that is a posterior, superior, and lateral. So these all semicircular duct, these open into the utricle, and the saccule has the opening from the cochlea. So by this opening, the connection between the saccule and the cochlea is known as ductus reunion. Again, this has been asked in the exam. Now, this length of the basal membrane, it increases as we proceed from basal coil towards the apex or the apical coil. So that is the reason why higher frequency of the sound are perceived by the basal turn of the cochlea, and the lower frequency are perceived or carried away by the apical turns or the apical coil of the cochlea. Now let's talk about the utricle. This utricle lies in the posterior part of the bony vestibule. I told you that this vestibule laterally it connects with what? Just try to remember. Just look back into the slide. I'll not answer this. So I told you that externally this central chamber, this vestibule, laterally it is connected to some structure, and medially lies the utricle and saccule. Okay, so let's talk about utricle. It lies in the posterior part of the bony vestibule. The utricle and saccule, these both have the sensory epithelium, but is known as macula. So macula is the sensory part of the utricle and saccule, and it is responsible for linear acceleration and deceleration. Now tell me, for the angular acceleration and deceleration, which structure is responsible? For the angular acceleration, semicircular canals are responsible, and utricle and saccule, they are concerned with the linear acceleration and deceleration. I already told you that it receives 5 openings from 3 semicircular duct, and it is connected to the saccule by means of utriculosaccular duct. As you can see in the diagram, this is my saccule and this is my utricle. So they are connected by utriculosaccular duct. Saccule, again, the sensory part is known as macula. Now let's talk about semicircular duct. We know these are 3 in number, and they have 3 ampulated end and 2 non-ampulated end. And these semicircular duct, they have the sensory neuroepithelium, which is known as crista ampullaris. And this crista ampullaris is responsible for the angular acceleration and deceleration. And this, we all know about the otolith. Have you heard about otolith? That is a BPPV, responsible for BPPV. So these otolith or the otoconia are a calcium carbonate crystal present in the semicircular duct. So when they move, they can stimulate this crista ampullaris. They dislodge basically into the semicircular duct from this crista ampullaris. Now let's talk about organ of Corti, which is the sensory organ of the hearing. Look at the diagram. This is the basilar membrane, and over this organ of Corti rests, which consists of inner hair cell and the outer hair cell. These inner hair cell are single row, that is in one single row, whereas the outer hair cell, there are in 3 to 4 rows. So sound energy is converted into the electrical energy by means of inner hair cell. The outer hair cell, their role is to modulate or modify or to manage the function of inner hair cell. So the transduction is from or by means of inner hair cell, whereas the outer hair cell, they just modulate the function of inner hair cell. Then there are other cells also, which are known as the Dieter cell or the Henser cell. You can see this is the cell of the Henser and cells of the Dieter. Okay, these are some of the supporting cells, and from these you can see in the diagram also, these outer hair cell projection, they are lying into some jelly like material which is known as tectorial membrane. So understood what is tectorial membrane? The outer hair cell projections, they are resting into some gelatin like material which is known as tectorial membrane, and whenever this sound energy hits to suppose scala vestibuli, then transmit to the scala tympani. So this parallel movement will cause the movement of the basilar membrane, and thus this movements or the mechanical energy will be transmitted to the organ of Corti, leading to stimulation of the hair cells, and then these hair cells will convert this mechanical energy into the electric energy, which is being transmitted by means of auditory nerve.